So it's really quite amazing that you've spent the last 40 years or so, roughly, thinking about and describing the systems that we're really striving to create today using blockchain technology. So I'm really curious as to what you believe to be the main contributing factors that ultimately allowed you to envision such a radically different future in which secure multi-user interaction was able to take place.
Okay, I love this question. There's several key elements that were quite formative in my uh, uh, being able to see forward in these ways. Um, One thing is really very generic, but I think should not be underestimated in its importance, which is I was a big reader of science fiction that um, and taking very seriously from having been exposed to so much science fiction that technological progress shapes the future more so than anything else, which I still believe, and that it can take the future in surprising directions, uh, and that the future can be very, very different than the present, and it can happen fast. So, just sort of generally approaching all these matters with that seriousness about technology and progress and change of the future. Um, I can, in 1975, a friend of mine handed me Ted Nelson's book, Computer Lib Dream Machines, which was Ted Nelson, a really great visionary, uh, his his dreams about the future of computing, which was largely focused on the future of uh, interactive systems. Um, but uh, it wasn't a shallow focus on the screen. It was a really quite a deep focus, driven by the notion of people interacting with information on computer screens. Um, uh, but he was one of the two great hypertext visionaries. Very brief history of hypertext, just sort of high, biased towards highlighting, how it influences the main story I'm telling today. Hypertext itself started, in some sense, with Vannevar Bush's 1945 paper, As We May Think. Vannevar Bush was President Eisenhower's science advisor. He published a article in The Atlantic imagining what we would now call a user experience of hypertext documents, of linked documents, but he was imagining it all. He was painting the picture as the future with microfilm and microfiche technology, because that's all that they had to imagine it with. Um, Doug Engelbart and Ted Nelson both remember reading that article as children. Um, they grew up in the 60s to form the two great hypertext visions. Uh, Doug Engelbart, the augment system, NLS, which, by the way, all of the Kikos design documents were done in augment. Um, and a lot of the beauty of Kikos is they attribute to the to what was some of what was different in the design process that was possible to them because they were writing their documents in augment. And then also Ted Nelson in the early 60s formed the Xanadu vision and started building that out, and then really explained it very, very well in Computer Lib Dream Machines. When I read Computer Lib Dream Machines, I was really grabbed by the whole Xanadu vision, and ended up deciding that um, that this whole vision of computation from that's laid out here was very much the computation that I wanted to learn about. So I ended up in the summers between some, between school. During the summers, I apprenticed myself for free to Ted Nelson. I contacted Ted Nelson, but apprenticed myself to him. I ended up working on the Xanadu project, becoming the chief architect of what became known as the Xanadu Green architecture. But at Xanadu, part of Ted's vision was, and this is why the book is called Computer Lib, is computers and decentralized networks and worldwide hypertext publishing as a liberating force. We were, both Ted and I were quite terrified of the vision of laid out by George Orwell in 1984, but being Ted's apprentice, I very much absorbed this notion of the future is a choice. We can either end up in a world of 1984 style oppression, or we can end up in this world of hypertext publishing, of electronic publishing on computer networks, if we can figure out how to build those things out in a way that was free of censorship, free of modifying of history, which was one of the main forms of oppression from 1984, and free of monitoring, something that was inherently private. One of the things that was an essential part of the Xanadu vision and then of the Xanadu architecture was for nobody to be able to know what you're reading. That's the thing that I found most bizarre about the hypertext system that that then took over the world, the web, which is with the web architecture, not only can the server that serves the document know what document you're reading, but with the Web 2 architecture, they can know where you are in the document, how much time you're spending looking at which paragraph, how your mouse is moving. The degree of violation of privacy of people reading things to take in information is just something that it just not in my wildest nightmares would I ever have thought that masses of public would have accepted that kind of loss of privacy. So in any case, I very much absorbed from Ted this notion that we're at a choice point, that humanity is at a choice point, that these electronic networks are coming, and it could be a 1984 style nightmare, or it could be a great liberating force. And I also very much, sort of took up the idea that it was our responsibility to figure out how to build the great liberating force, that how it turns out depends on what we build. And we, and
so it's really fascinating and a bit humorous to hear you say, never in your wildest nightmares would you have envisioned the lack of privacy that we experience today in the Web 2 world. So given that you all had such great visions for what would become the internet, what went awry that eventually led to the web being so invasive and just lacking in privacy?
So part of why it went awry was actually, I'll say, my fault, or primarily my fault, which is in 1989, Dean and I both left Xerox PARC to form the newly funded Xanadu project. Xanadu had been going on unfunded on a shoestring throughout all of this time until 1989, when Autodesk decided to fund it. We then formed this really wonderful startup build out, to really build the Xanadu hypertext system. And there were two things we got wrong. One was we had a notion of what features you needed simultaneously to have a hypertext system that would create good social emergent effects. There were basically 7 fundamental requirements. And this is laid out in my paper, The Open Society and Its Media is what those 7 fundamental requirements were. And we built a system that did those, but it took us longer than was expected. And we kept having these triage meetings where we tried to figure out if we could drop something in order to get to market faster. And we kept talking ourselves into the fact that, well, if you drop these things, you get social pathologies. So you really need all 7 in order to get the kind of beneficial emergent social effects on the evolution of society's knowledge that we were looking for, that were motivating us. And as a result, the project went long enough that Autodesk, our funder, ran out of patience, well, partially due to a management change at Autodesk. So we were already in beta with the product. It was not in beta. We already had the features working. We were demonstrating we had the features working, all 7 features, but it was quite a long way from really having been something that was a commercially viable system at that time. By the time we ran out of funding. The other thing we got wrong is none of us appreciated what we would now call open source, which was then called free software from because Richard Stallman's way of explaining the virtues of free software didn't make sense to us. And it wasn't until later with the open source movement that we really came to understand the power of it. But the result of those two things is that we built something where the technology itself was quite intricate and needed a bunch of work before it could be used commercially. And it was proprietary. So without funding, it was hard to figure out how to continue to advance the system. The web came out with 2.5 of our 7 elements, and took the world and was a simple architecture and was open source, simple enough with text-based protocols, which is still kind of insane. Text-based protocols so that people were able to put together web servers with very, very little software, which itself is quite wonderful that you could do it so simply. But with 2.5 of the 7 elements, it proceeded to have all of the social pathologies that we were worried about. In my paper, The Open Society and Its Media, there's 2 paragraphs in that paper that I would say really explain pretty damn well what we then later came to call filter bubbles and echo chambers and all of those things. So that's how Xanadu died, and it was in the light of the death of Xanadu that Dean and I then left Xanadu and formed with Norm Hardy and others Agorics in the mid-90s, dropping the hypertext part, but taking forward the liberation goals, the software, decentralized cryptographic software systems, but now general purpose computational systems that could support hypertext and other things, could support just general purpose, decentralized, secure, permissionless programming. If you can support that in general, then any particular decentralized application like hypertext, you can, of course, build out of that. So that was one of the formative elements. Another formative element is I had, what was the time frame here? I'd say probably early 80s. I was a really big fan of object-oriented programming and then of actors. And separately, or thinking it was completely separate, I was also becoming very, very interested in economics, and in particular in the writings of an economist, Fredrich Hayek. And I was explaining, I think I would say around 1983, I was explaining to my friend Eric Drexler about the virtues of encapsulation in object-oriented programming, how for every piece of data that it's encapsulated within an object, so that with regard to the there's only a finite amount of code that you have to look at to know whether the invariants are being maintained in the data, that this coupling of encapsulated data together with code. And Eric said, oh, that's like Hayek's explanation of why property rights are important. And that was the big aha experience that brought the thinking about computation and the thinking about economics together in my head, realizing that they were, at an abstract enough level, solving the same sets of problems in the same sets of ways. That the way I would, the way I've been putting it, since then, or more recently, is both large object programs and the human economy as a whole are networks of entities making requests of other entities. And that the nature of the request making is the request contains both an informational component and a rights and incentive component, that there's the transfer of information in the request, but also the transfer of rights. So this really led to, so it was from 83 to 88 that Eric and I worked on the Agoric Open Systems papers published in 88. And that very much caused me to see the foundations of the economic issues just very directly in language-based terms. And that's what led to the appreciation of capabilities, which is capabilities are the rights that are transferred in a request from one sovereign entity to another sovereign entity. And that's, seeing that from the object-oriented perspective and seeing that from the economic perspective, the only kind of economics that you can map to object-oriented computation is one that recognizes the object reference as the right. So it very much led us to a much deeper appreciation of the capability perspective as sort of the only perspective that supports decentralized rights ownership and rights transfer as the foundation of computation.